7.2, using proportions to solve geometric problems. Pretty vague.
It's only one page.
Yep, just one page. So a scale drawing is a drawing that is the same shape as the object that it represents. The scale is the ratio that describes how the dimensions in the drawings are related. Okay, so the ratio of the dimensions. So does that fit in with they're the same shape but different sizes?
Yeah.
Okay. So, additional properties of proportions, and I actually showed all of these but one to you on that last worksheet. So we have the reciprocal property. So if A over B is equal to C over D, I can reciprocate both of them and get B over A equals D over C. Did I show you on that one example that we did all three different ones?
Yeah.
Okay, now if AB equals CD, then AC is also equal to BD. So what happened there?
You switched it.
Right, when I had the corresponding across from each other in the first one, I put them above and below each other in the second one. Does A still correspond to B?
Yeah.
Yes. Does C still correspond to D? Yes. The only thing I couldn't do is put that D in the numerator because it does not correspond with A. So the next thing we can do, this is kind of an interesting one. It works when you don't know a whole measurement, so it comes in handy. You'll actually kind of use it a lot today. So if I have AB is equal to CD, okay? AB over B is congruent to C plus D over D. So what that would mean, I'm just going to draw a oh, we're doing lengths. Sorry. Okay, so if I have these lengths, so AB would give me the what?
That side.
The whole thing.
Yeah.
So if I was looking for the whole thing and I had just part of it, I could use this. Now, could I use A and A plus B? Could I do that? Yeah. Okay, so that comes into play when I have side pieces like that. And I will show you examples. You will have many examples, so you'll be fine. Okay, so now we have 3 examples. So we know these 2 triangles are similar because they're one triangle in the other, correct? Okay, so find X. So we're looking for this piece right here. Well, do I have all the other pieces that I need?
Yeah.
Okay. Now, I always try to put X in the numerator because I have to do less work. So, X is in the numerator. Do you want to put 5 in the denominator or 5 across from it? I usually put it in the same one. Okay, so X and 5 are in the same side of the triangle, yes? So now what corresponds to X? 8, so it goes in the denominator. What corresponds to 5? 20. Now, I could have written it X over 5 equals what over what? 8 over 20. I also could have written it 5 over X is equal to what? 20 over 8. I also could have written it which way did I just do? This one, right? I also could have done 8 over X is equal to what?
20 over 5.
20 over 5. Do you see all those different ways I could have written it?
Yeah.
But do you see how these are corresponding, these are the same side, these are the corresponding pieces.
Yeah.
These are the same side, these are the corresponding pieces, and these correspond. The reason why I like to leave the x in the numerator, because then I only have to multiply across by 8, and I leave the x alone. Because I could multiply by 20, but then I'd have to do what with it? Divide. So can't it just stay where it's at?
Yes.
Yeah. So I have 5 times 8 over 20, 5 and 8, or you want to reduce 5 and 8 or 8 and 20?
What? What'd you say?
Does 5 go into 20?
Yeah.
Yes. So how many times?
4.
4. Does 4 go into 8?
Yeah.
Yes. Twice.
Twice. So my answer is what?
2.
2.
I just did it like.
Okay. You could have done 40 divided by 20, but that's pretty easy. You get 2. But what if I had like 178 divided by 14? Would that be harder to do? So reduce before you multiply.
It's actually really fun.
Okay, so now I want what? What do I want?
You want the whole thing?
I want the whole thing. So I'm going to have to use some of this addition, aren't I? Okay, so I'm looking for x. That's what I always write in this numerator. That's just what I do. Okay? And I make my other fraction. So I'm going to put x over 4. Why did I put x over 4?
Because they're the same side.
They're on the same side. Could I put the 4 right here?
Yeah.
Yep. Okay. So x over 4. So what corresponds to x?
6.
No. X is the whole thing. So 3 plus
6.
6. What corresponds to 4? 6. Do you see how 3 plus 6 over 6 is the same as a plus b over b?
Yeah.
Yep. Okay. So this is 9, yes? Okay. And multiply over by 4. So what do you want to reduce? I got 9 over 6 times 4.
How about?
The 9 over 3. You're running.
We're gonna reduce 9 and 6.
Okay, so 9 and 6 reduce to what? 3 over 2. Does 2 go into 4?
Yeah.
How many times?
2.
2. So 3 times 2 is
6.
6. So x is
6.
6. So what would you do if I said this is y down here?
We definitely find y. 4 minus, or no, 6 minus 4.
6 minus 4?
You get y.
Okay, that's great, but what if you messed up on 4?
What?
What if 4 isn't right, or 6 isn't right?
Well, then you do y plus y.
Let's
y
do a
over
ratio.
4, y over 4 equals 3 over 6.
Y over 4 equals 3 over 6. This is to my point. Always use what you're given, not what you find. Because what happens if you messed up?
Then you're wrong.
Then you're wrong both times, not just one, right? And this is a check on both of them, isn't it?
Yeah.
Okay, so I'm going to reduce this to 1 and 2. How about you guys?
Yeah.
And then multiply over by
4.
4. And 2 goes into 4 how many times? Twice. So 1 times 2 is 2.
Shush. You think you're-
Okay, so it was 2, and we could have done that by 6 minus 4, but does it check that we're right?
Yeah.
Yeah. Okay, I want you to try this one on your own. There's a place online for you guys to turn in yesterday's, okay? Can I start?
Mm-hmm.
No?
Yes.
Maybe at 33.
15 plus 18?
Oh, what'd you reduce by?
3.
Oh,
And then 5. Because, Jessica, this is the whole side.
Mhm.
So it has to be corresponding to the whole side. So 15 plus 18 is 33.
Right, hold on. I do that. And
And then I had 33 over 15, so I took out a 3
then,
and got 11 over 5.
Oh.
And then I multiplied by 10,
Mm,
and 5 went into 10 twice.
yep.
So 2 times 11 is 22.
Mm.
Now, this is a perfect example where reducing makes it better, because if
Yeah.
not, you had 330 divided by 15.
Yeah.
Yeah.
So I did reduce, but I don't know. So I got 33 from 15 and 18.
Mm-hmm.
Okay.
I added right, didn't I?
Oh,
333, yeah.
yeah. I got, okay.
Okay.
33. All right.
Okay. Questions?
okay.
Okay, so I handed you a worksheet. And I want to go over it, some of them, so you understand what it's asking you. So number 1, it says if 6 over x equals 5 over y, then 6 over 5 equals what over what?
X over Y.
X over y. So then we're going to go to 3. I moved it up too much. Okay. So you have to look at what it's asking you. If x over 4 equals 7 over y, then x plus 4 over 4 equals
Y plus
Or
over
over
7.
seven.
Y plus 7 over 7.
y plus 7
Equals.
over
7.
over
4?
Y.
y.
Oh,
Why?
Because the denominator stays in the denominator on that one. Because it went to the denominator, so you have to keep that. Okay, so you have to be a little bit careful on those.
Yeah.
Okay, so then the next one, determine if the statement is true. So we're going to use those rules that I gave you, and we have to see if we can use that rule or not. Okay, so 5. If it's not true, you have to fix it. Okay, so I have x over y equals 8 over 3. So then y over x equals 3 over 8.
Yes.
Yeah.
True.
That is true.
Okay. How do we explain why?
No, if it's false,
Oh.
you have to say what would make it true. Okay, 6 or 7, sorry.
That's.
So I have x over y equals 8 over 3. Then x over 8 equals 3 over y.
No, it's false because Y would have to be over 3.
That is false.
Has to be corresponding. Yeah.
So it needs to be y over 3. And you just do that. False, and what it needs to be is that. Make sense what I'm looking for?
Yep.
Okay, 9. If x over y equals 8 over 3, then x plus 8 over 8 equals y plus 3 over 3.
I don't
Wouldn't that be
I don't
crazy?
think so.
I don't know.
Well, can I write this as x over 8 for 9? Can I write it x over 8
Oh, yeah.
Yeah.
equals y over 3?
Yeah. Yeah.
So then would that go with x plus 8 over 8 and y plus 3 over 3?
Yeah.
Yeah, so they used 2 rules, didn't they?
Yeah,
So it's true. So some of them are a little tricky.
triggers.
Okay, so then on the bottom is what we just got done doing. And then multiple choice is that. I just wanted to go through those with you so you knew what I was expecting. Okay?
Okay.
Remember, there is a place for your worksheet from yesterday to go and today. So get, yep,
What
on
did you
Classroom.
say?
There's a place for yesterday's and today's.
Okay, that is not what this, my brain processed.
Okay,
That my brain also processed what you processed.
Yeah, I think.
anyway,
It sounded funny.
get busy. You guys